This problem wants us to factor. Factoring is the reverse of multiplying. Now we think of the reverse of multiplying as dividing, and it is. But the word you usually use when you're talking about expressions is factoring. So what I want to do, it's kind of like if I said, hey, tell me what the factors of 24 are. You could break that up and you could say either 8 times 3, or you can say 6 times 4, you could say 12 times 2, or you could even say 2 times 2 times 6, or 2 times 2 times 2 times 3, etc. And these are all factors, right, of 24. So if I said, tell me what the factors of 24 are, I'm basically saying, what multiplies together to make 24? And that's the same thing that we're doing up here. I'm saying, what multiplies together to make this? Or another way I could say it is, what can you divide out of that evenly? Kind of like I could say, what can I divide out of 24 evenly? Any of these things are factors because they divide out evenly. Alright, so how do we do that? Well, we look for, in this, the first thing we do, factoring has many facets to it. The first thing you always want to look for is a GCF, a greatest common factor. So the greatest common factor means what factor do all of the terms have in common? What factor do all of the terms have in common? And specifically, what's the greatest one of those? And so if you look at these things, well, you might say, well, they all have, what factors does 8y cubed have? 8y cubed has an 8 in it, which means it's got a 2, it's got a 4, it's got 8, it's got y, and it's got another y, and it's got another y. 32 has what? 2 and 16 and 8, etc. I could do this for all those, and it has y times y times y times y. Negative 56 has 2, and I could keep going. The best way to do these things is by factor trees, and think about 8. 8 equals 2 times 2 times 2. That's what 8 equals. 32 equals, you might want to say, oh, 32 equals 8 times 4, or you might want to say 32 equals 16 times 2. It doesn't matter where you start. If you break it all the way down, you're going to get to its prime factorization, which is 2 times 2 times 2 times 2 times 2, or 2 to the 5th. This is 2 to the 3rd. 56, let's break 56 down. 56, take half of it, that's 2 and 28. Take half of 28, 2 and 14. Take half of 14, 2 and 7. So what is 56 as a prime factorization? It's 2 cubed times 7. That's the best way to do this. That's the best way to do these kind of problems, is to think about these numbers as their product of primes. And when you do that, it's really easy to see what they have in common. So let's take a look what they have in common. Well, they all have 3 y's in common, right? Each one of them has 3 y's. And each one of them, look at their product of primes. Each one of them has 3 2's in common. So the greatest common factor is 2 cubed, or 8, y cubed. Alright, so once we figure out what that is, now we factor it out of each term. And this is just the opposite of what you did when you distributed it into the term. So what we're going to do now is we're going to take, this is where people get, a lot of times people get really confused when we talk about this, but what I'm going to do is I'm going to take that out, 8y cubed, I'm going to take that out of each term. It's like I'm undistributing it. And then you tell me what's left over if I take it out. Well, this is easy, this one over here. What's left over if I take out 8y cubed? Don't say 0. 1 is left over. You've got to hold the place. What's 8y cubed divided by 8y cubed? 1. What's anything divided by itself? 1. So I said it's easy, but actually that's not very easy. That's hard for a lot of people. What's left over in this first term if I take out an 8y cubed? Well, how many y's are left over, first of all? There's 2 left over. And how many, what is negative 56? If I take an 8 out of it, I'm going to have a negative what left over? I'm going to have negative 7 left over. By the way, it's right there. You can see it right there. And if I take an 8 out of 32y, or 8y cubed out of 32y, don't forget the plus sign, how many y's are left over? Just one y. And 32 divided by 8 is 4. There's 2 2's left over. Plus 1. And that's your answer. You factored out the GCF. And how can you check it? Well, first of all, make sure that there's no other common factors for all three of those terms. Now you might say, well, can I take out another y? No, because this 1 doesn't have it. These ones might, but it has to be common to all of them. So if you know that there's no other factors, then all you have to do to check it is just mentally distribute this back in like this and check to make sure that that would have given you back to your original problem. That's how you factor with the GCF.